Hello team! With this lesson we start learning Spring Framework for web applications. There is a wide range of approaches in web applications development. To proceed with this lesson, you need to be familiar with the World Wide Web concept and have basic understanding of Java servlets. We are going to start the lesson from the overview of what Spring MVC is and why we need it. We'll quickly remember what MVC Pattern is. Also, in this lesson we are going to talk about Front Controller Design Pattern, and you will understand what this pattern is about and what DispatcherServlet is. After that, I am going to explain you flow of program execution in Spring MVC. And once we learn theory, we'll jump to practical example. In this lesson, we are going to create our Hello World Spring Web project. You are going to learn new Spring configuration for web applications in this lesson. We'll learn such annotations as request mapping and enable web MVC. We are going to configure ViewResolver bin, and we'll learn interfaces and classes that are needed for Spring web application configuration. And at the end of the lesson, we are going to make a summary of all advantages of Spring MVC. Let's start our lesson. So, before diving deeper into the REST services and complex web application, we are going to learn some basics and fundamentals about Spring Web Application Configuration and Spring MVC. It is important you are familiar with MVC Design Pattern in order to understand the general terminology that we are going to use in the lesson. Just in case, you can find a lesson about Spring MVC Pattern in my course Java from Zero to First Job. From this course, you already learned that Spring MVC is a separate project. And why we start learning Spring for web development with the Spring MVC? The Spring MVC framework is the foundation of the building web application with Spring. It powers a wide range of web applications, from traditional MVC style applications all the way to stateless REST APIs. Let's learn Spring MVC better. It follows the Model View Controller Design Pattern. It implements all the basic features of a core Spring framework like inversion of control, dependency injection, and we already learned what an inversion of control and dependency injection are, and we learned them on practice. Feel free to watch previous lessons from this course if you want to refresh the knowledge. MVC stands for Model View Controller. Let's just quickly remember why we need this separation of concerns and what element is responsible for what. Model. A model contains the data of the application. The model component corresponds to all the data-related logic that the user works with. This can represent either the data that is being transferred between the view and controller components or any other business logic-related data. A data can be a single object or a collection of objects. Controller. A controller contains the business logic of an application. Controllers act as an interface between model and view components to process all the business logic and incoming requests, manipulate data using model component, and interact with the views to render the final output. View. A view represents the provided information in a particular format. The view component is issued for all UI logic of the application. Usually we use HTML, CSS, JavaScript, JSP plus GSTL, and other technologies to create a view page. Spring also supports other view technologies, such as Apache Velocity, Symleaf, and FreeMarker. But I can't state that they are popular enough in order to spend a lot of time on learning them. Please don't take me wrong, I'm not saying that Symleaf is bad. It is also a great technology which is worth of your attention. Just based on my experience and experience of my students, on the market currently there is more preference to the React.js, Angular, and sometimes JSP with GSTL for the view front-end part. But things are changing quickly in IT world. Anyway, understanding the concept, you will understand different frameworks and technologies. The main thing is to understand core principles. One of the key principles in Spring MVC is the concept of the front controller. The front controller software design pattern is listed in several pattern catalogs and related to the design of web applications. It is a controller that handles all requests for a website, which is a useful structure for web application developers to achieve flexibility and reuse without code redundancy. In Spring Web MVC, the DispatcherServlet class works as a front controller. It is responsible to manage the flow of the Spring MVC application. In other and simple words, imagine regular servlet. Do you remember what a servlet is? In case you don't remember what a servlet is, you definitely need to remember this by watching my course for Java web developers. So, DispatcherServlet is a class that receives the incoming request and maps it to the right resource such as controllers, models, and views. On this simple illustration you can see the flow of execution in Spring MVC. And I want you to understand the theory first before we jump to practical exercises. As you can see on the slide, all incoming requests are intercepted by our front controller, by the DispatcherServlet. What happens next? Spring stores the configuration with the list of all controllers. If you remember our lesson about basic beans configuration, you should remember controller annotation. So the controller is also a component, and its life cycle is managed by Spring Container. And Spring knows the mapping of each controller. So DispatcherServlet forwards the request to the controller that is supposed to process the request. Spring stores URL mapping with classes and methods that should be invoked. The controller component prepares model, actually data that can be passed further to the view. There are different ways of how you can write methods in controller and what they can return. For example, they can return model and view object, or they can return just the name of the view, or they can return a raw response body. It depends on the configuration and what we would like to achieve. All these edge cases and examples we are going to learn on practice. Based on the answer from controller, the DispatcherServlet uses ViewResolver to resolve the view, because on this stage we need to understand how response will look like and what we need to send back to the client. I believe that by this moment you already have high-level understanding of Spring MVC. Now it is time to understand it better with the code examples. So, let me start screen sharing. Before the lesson I prepared demo project for you. And now we are going to review it line by line. As always, you can find the reference to the source code examples in attachments to the video. So, the first thing that we have to do, let's create web project. You can create web project either with Maven build tool or with Gradle build tool. This is lesson not about Maven, Gradle, or how to create web projects. This is lesson about Spring development for web. That's why I assume that you know how to create web project. In case you have any difficulties, please refer to my general course Java for Web Development or Java from Zero to First Job, where we learned such basics as creation of project for web development. In this particular example, as you can see, I use Maven build tool. Disregardless of which automation build tool you use, we have to add dependency for Spring MVC. You can see it here. I recommend you to use the latest available version. The version of the Spring MVC is stored here in the properties. I also added JavaServlet API dependency here. If you saw my lessons about Java for Enterprise Edition, you should be aware about the difference between JavaX and Jakarta API. I had a separate lesson where I explained the difference. In short, Jakarta API is something what is supported nowadays by Eclipse Foundation, and JavaX EE, that is something what is not developing anymore. In general, for the sake of this course, Jakarta and JavaX EE API contains classes with the same class names that serves the same purpose. That's why we wouldn't be impacted too much. Just the base package name for all classes will be started from JavaX instead of Jakarta. And it is not because I don't want to work with the latest version of Java EE. Spring and Spring Boot currently only support Java EE and not Jakarta EE. By the way, this also means that it will only run with Java EE compatible servers. In all our previous lessons we used Tomcat version 10, but Tomcat 10 web server is an implementation of the Jakarta EE specification, which currently isn't supported. So the only solution for us is also to download Tomcat server version 9. You can see that I added Tomcat 9 into the servers section too. Also, you can see that I've added GSTL dependency here. Okay, now that is enough dependencies for our Hello World example, and we can proceed. One more, just Eclipse related configuration. Mouse right click on the project, then select Properties. Search for project facets here in the list. In order to run your web project from Eclipse on the Tomcat version 9, you should have Dynamic Web Module version less than 5. In my case, I have version 4, and that is fine to run the project successfully. I hope this would save your time in case you would have issues with deploying your project from the Eclipse directly to the Tomcat server. Let's move on. Let's create our first controller now. I created a class that is called Hello World Controller. Two main annotations that we are going to use are controller annotation. This annotation should be familiar to you from our lesson about beans configuration and request mapping. Let me tell you a little bit more about request mapping annotation. Request mapping is one of the most widely used Spring MVC annotation. Request mapping annotation is used to map web requests onto specific handler classes and/or handler methods. Request mapping can be applied to the controller class as well as methods. When we use this annotation with class, we configure the base URI for the whole controller, and we can specify the URI on the level of each method in addition, like you can see on this example. Hello World controller will have base URI test, and method Hello World will be mapped to Hello World URI. So the full URI would be test plus Hello World. Is it clear? Don't worry, I'm going to show you this in the browser in a minute. Request mapping is very powerful annotation because we can configure request mapping as we need. Not everything you need to remember right now in this lesson, but we are going to learn how to work with this annotation gradually. But something I would like already to share with you in this lesson. First of all, in case it would be needed, you can pass multiple values for pass. You can see here that value takes an array of strings. The next thing here, that you can use headers attribute to specify headers that should be present in the request, in order Spring would invoke the specific method. In other words, you are able to add condition for request mapping. Also, you can specify array of methods, because sometimes we would like to have different behavior for different HTTP requests that are sent with the help of different methods. But at the same time, we would like to keep the same URL. Using method attribute, you can configure this. In our particular example, we tell to the Spring that in case request will be sent to this resource via get method, then call this method. And in case request will be sent to this request mapping via other HTTP method, this code will not be invoked. Is that clear? Even in case something is still not clear, please do not hesitate to ask your questions below the video and I will be happy to answer. Also, we can create request mapping with produces and consumes. Request mapping provides consumes and produces variables where we can specify the request content type for which method will be invoked and the response content type respectively. There are much more things to tell, but let's go one by one. I promise you we'll learn all things gradually. For now, we just create simple hello world controller. And our method returns us hello world string. What is this? This is actually the name of our JSP file. But in order to resolve this view name and forward request to that view, we still need to configure ViewResolver bin. I'm going to show you how to do that. Let me open a class that is called webconfig. To enable Spring MVC support through a Java configuration class, we just add the enable webMVC annotation. Adding this annotation to a class that is marked with a configuration annotation imports the Spring MVC configuration from webMVC configuration support class. This will set up the basic support we need for an MVC project, such as registering controllers and mappings, type converters, validation support, message converters, and exception handling. If we want to customize this configuration, we need to implement the WebMVC configurer interface. Important thing here, you can see that I configure bin of ViewResolver. Why do I need it? This is needed in order I wouldn't specify the path to the views and extension of the files each time. If you're a student of my Java from Zero to First Job course, and you remember how we did our online shop from scratch using just servlets, you remember how we created paths to our view resources. ViewResolver bin helps us to simplify things. You can see that I set prefix where all my views will be stored. In the webinf view folder, and here is this folder in my directory tree. And I also set suffix in order to forward requests to the files with a JSP extension. Can you understand now how paths to the Hello World JSP will be built? I hope so. Please ask questions in case the example is not clear. And also, do not forget to add component scan annotation in order to scan all the required packages in order to initialize all the required bins and inject dependencies. We're almost done. Why almost? What is left? The only thing that is left is configuration of our DispatcherServlet. Now we actually need to configure something what will be responsible for mapping requests with our controllers and with methods within our controllers. As always, there are two ways for configuration, with XML and with annotations. Let's review both options. And finally, to force our application to load this configuration, we need to create a configuration class. Let me show it to you. It is also located here, and it is called MainWebAppInitializer. This class implements WebApplicationInitializer interface. The interface to be implemented in Servlet 3.0 plus versions environments in order to configure the servlet context programmatically. Implementations of this interface will be detected automatically by Spring Servlet Container Initializer, which itself is bootstrapped automatically by any Servlet 3.0 container and higher. To learn more about bootstrapping mechanism, you can investigate source code and Java docs for Spring Servlet Container Initializer class. Let's explore the details of onStartup method that we override in our main web app initializer class. First of all, we create object of AnnotationConfigWebApplicationContext. This is essentially the equivalent of AnnotationConfigApplicationContext that we used in our previous lesson, but this class is for web environment. We register our webConfig class in our context, because our webConfig stores required configurations that we wanna use for our application. The next thing that we are doing here is attaching of the ContextLoaderListener to the servlet context. Why do we need this? The ContextLoaderListener is one of the essential components of the Spring MVC framework, probably the most important after the DispatcherServlet itself. It is used to create the root context and responsible for loading beans, which are shared by multiple DispatcherServlet, like beans related to the service layer and data access layer. In general, when you develop Spring MVC-based web applications and also using Spring in the services layer, you need to provide two application contexts. The first one is configured using ContextLoaderListener, and the other one is set using DispatcherServlet. The DispatcherServlet is responsible for loading web component-specific beans like controllers, ViewResolvers, and handler mapping, while, as I said before, ContextLoaderListener is accountable for loading middle tier and data tier beans, which forms the backend of Spring applications. The ContextLoaderListener is like any other servlet listener, and it has to be declared in the deployment descriptor to listen to events. It listens for startup and shutdown of the server by implementing Servlet ContextListener, and accordingly creates and destroys Spring managed beans. In the next row, we can see the variable of nested interface, dynamic, from the interface servlet registration. We use dynamic interface here because this is the interface through which a servlet registered via one of the addServlet methods on servlet context may be further configured. And you can see here that we add to the servlet context the instance of our DispatcherServlet. To create DispatcherServlet, I create object of generic web application context. It is a subclass of generic application context, suitable for web environments. Implements configurable web application context. The next thing that I do here is invocation of setLoadOnStartup method. What this method is about? The method sets the loadOnStartup priority on the servlet represented by this dynamic servlet registration. A loadOnStartup value of greater than or equal to 0 indicates to the container the initialization priority of the servlet. In this case, the container must instantiate and initialize the servlet during the initialization phase of the servlet context. That is, after it has invoked all of the servlet context listener objects configured for the servlet context at their servlet context listener ContextInitialized method. If load on startup is a negative integer, the container is free to instantiate and initialize the servlet lazily. The default value for load on startup is -1. As you know well, servlet is loaded at the first request usually, because of default value -1. That means it consumes more time at first request. If you specify the load on startup in WebXML, servlet will be loaded at project deployment time or server start. So, it will take less time for responding to first request. If you pass the positive value, the lower integer value servlet will be loaded before the higher integer value servlet. In other words, container loads the servlet in ascending integer value. The 0 value will be loaded first, then 1, 2, 3, and so on. So with this line of code, we load our DispatcherServlet on startup. And we add mapping to it, the root of the application. That means that DispatcherServlet will handle all requests to the application. That is exactly what we need. This is an example of annotations-based configuration. Let me also show you XML-based configuration. It is similar and will bring us to the same result. Like we have already discussed in our previous lesson, it is only up to you what type of configuration to choose. It is a matter of style, whether you use annotations or XML. The main thing is to stay consistent. If you want to remember advantages and disadvantages of annotation and XML configuration, please refer to the previous lessons in this course. So, in order to configure Spring Web Application with XML, we need 3 XML files. 2 of them are located in the resource source folder. Let's look at them. AppConfig.xml is a file for Spring configuration. You can declare beans here. We enable auto-detection by registering the context component scan element and provide the package to scan. The next file, WebConfig.xml file, will configure Spring MVC. The MVC annotation-driven element will enable Spring MVC support. Finally, we register the internal resource ViewResolver bean, which will resolve the returned view name to the real location of the view. All this configuration is familiar to you already, because we have just reviewed example with similar configuration with annotations. And now we need to configure our DispatcherServlet, and we can do this in the web.xml file. Let me open it. We register the servlet and provide the location of the webconfig.xml configuration file using the init param. You can see here that I also configured load on startup element, servlet mapping element to map DispatcherServlet with the root, and I also passed the reference to the ContextConfig location, as you can see here. That's it. Basically, this configuration will bring us to the same result as Java-based annotation. It is up to you which approach you would like to select. Taking into account that we can't use 2 approaches simultaneously, I will keep web.xml file commented, and we will use Java-based configuration for the sake of this example. And finally, we are done with all configurations. Now we are ready to run our first example. Let me run this application on the web server. When the server is up and running, let's adjust the address here. We have the base name of our controller, test, and the address that is mapped with our method is hello world. When I send a request to this resource, DispatcherServlet handles the request and verifies it against all available mappings. finds the proper mapping, invokes the method from our controller that returns string. Spring understands that we return view name and uses ViewResolver bean to resolve this view name. That's how view file in the webin view folder is found with the extension GSP, because it is set so in the ViewResolver bean. Is it clear? That's how this example works. In case you have any questions, please ask them below the video and I will be happy to answer. I encourage you to download the source code from the lesson via the link that you will find in attachments to the video and run this code on your computer. I'm done with the demo. Let's just sum it up and quickly review the main advantages of the Spring MVC. Now, when you saw an example of Spring MVC and you can understand what it is, let's review advantages of Spring MVC framework. Separate roles. The Spring MVC separates each role where the model object, controller, command object, ViewResolver, DispatcherServlet, validator, etc. can be fulfilled by a specialized object. We are still going to learn other different objects. Today in the lesson we just had simple hello world example, and we have lots more to learn. Spring MVC is flexible. That means there are no super strict requirements regarding code structure, like for example inheritance between components or specific locations. MVC pattern is view agnostic, and I believe this is really a great advantage, because the pace of updates in the front-end technologies and the amount of frameworks is huge, and you are free to select any framework you wish to integrate it with the Spring MVC. Advantages of Spring Core, inversion of control, and dependency injection. On top of all Spring MVC advantages, we shouldn't forget that we keep taking advantage of Spring Core and inversion of control. We have container that helps us to manage lifecycle of our beans and dependencies between the objects. Rapid development. We can make a statement that the Spring MVC facilitates fast and parallel development because of the many ready-to-use out-of-the-box elements. In my opinion, these are key advantages of the Spring MVC framework. Definitely, in the internet you can find more of them, but I would say that these are the most important ones in comparison with other frameworks for web development with Java. Let's recap what we have learned in the lesson. In the lesson, we learned basics of Spring MVC. Now you know what it is and why we need it. We reviewed MVC Design Pattern. Also we learned Front Controller Design Pattern. I explained you what a DispatcherServlet is. We learned the flow of execution in Spring MVC. We created our first Spring Web application. Now you know what a request mapping and enable WebMVC annotations are. We configured bean of ViewResolver. We learned interfaces and classes required to configure Spring MVC project. And at the end of the lesson, we summarized advantages of Spring MVC. That's all for this lesson. Thanks a lot for your attention. Have a great day and see you in the next lesson.